is equal to x to the fourth plus 12x squared Okay, the following is a continuation of the 3.8 notes, and what I want to do is focus on question number 8 real quick. And what this is asking us to do is to first calculate dy dx using implicit differentiation, okay? And then we want to use this point given to us to draw the equation of the tangent line, or to write the equation of the tangent line. Okay, so the first thing I'm going to do is I'm going to erase this first. I'm going to go ahead and resize this, and just so we've got something to work with. But I want to calculate dy dx. Okay, I'm going to rewrite my function or my equation as y squared plus 3x is equal to 8. Okay, so what I want to do is I want to take my derivative with respect to x of everything here, okay? So I'm going to do that to every term. I'm going to take the derivative with respect to x of y squared, okay, plus the derivative with respect to x of 3x, and that's equal to the derivative with respect to x of 8. Okay, so as a result, the one thing I want to talk about here is that when I take my derivative with respect to x, I'm looking to see if it matches up with the variables in my term, okay, and it doesn't, okay. This is an x and this is a y. Since they don't match, I have to use the chain rule. Now, what I'm going to do is I'm going to take my normal derivative, which is going to give me 2y, so 2y, and then I'm going to multiply by the derivative of y, and I'm going to write that as dy dx, okay? And then, if I look over here, I see that x and x match, so I'm going to take my normal derivative. The derivative of 3x is just 3, and then here I don't have any x's, but I have a constant, that is 8, and the derivative of a constant is just going to be 0, okay? So what I have here is I have, almost my derivative, okay? I just need to isolate dy dx at this point, okay? And so I'm trying to isolate that. So I'm going to subtract 3 from both sides, and I'm going to end up getting 2y times dy dx is equal to negative 3, okay? And then what I'm going to do is I'm going to come over here and I'm going to write this. I'm going to divide everything by 2y. Divide by 2y. So I end up getting that dy dx is equal to negative 3 over 2y, okay? So what I want you to realize is that my derivative may contain x or y or both, okay? So in this case, my derivative only contains y, all right? So what I want to do is find the slope, or find the equation of the tangent line at this point, okay? So if I need an equation, then all I'm going to do is, I know that x is equal to 1, I know that y is equal to the square root of 5, okay? So, but I need to find my slope at this point. And the slope is generated by using my derivative and plugging in my y value of the square root of 5. So dy dx evaluated at y equals the square root of 5. Okay, we could put x equals 1, but there is no x in my derivative. So if I plug that in, I'm just going to get negative 3 over 2 times the square root of 5. Okay, and we can just leave it like that. Okay, and then we can just write our slope like that. So I'm going to go ahead and say that our slope has the value negative 3 over 2 times the square root of 5. Okay, so now my equation that we want to get here is going to be y minus the square root of 5. And that's equal to m, which is negative 3 over 2 times the square root of 5, times x minus 1. Okay, and you could simplify that, but let's just go ahead and leave it like that for right now. And this is in point-slope form. You want to just go ahead and do that. But, you know, the thing of it is, guys, is this stuff right here. Okay, and figuring out this part of the problem. All right, so let's go ahead and take a look at another question. Let's take a look at number 10. Okay, and so I'm going to come in here. Okay, so I want to write the equation of the tangent line at this point for 1. So the first thing I'm going to do, I'm going to come in here and I'm going to write x equals 4, y is equal to 1. Okay, but I don't know what my slope is. Okay, and I'm trying to find my slope. And the way I can find my slope is if I calculate dy dx, okay? So let me rewrite my equation here. I've got the square root. I got the square root of x minus 2 times the square root of y is equal to 0. Okay, so I'm going to take my derivative with respect to x here. Okay, so I'm going to do that to each term. I'm going to write d dx of the square root of x minus d dx of 2 times the square root of y. This isn't working out too well. Times the square root of y, and that's equal to d dx of 0. Okay, so as a result, what I can do here is I can now take my derivative, and I'm going to, notice here that I have an x and an x. So I'm going to take my normal derivative here. So I'm just going to get 1 over 2 times the square root of x is the derivative of the square root of x. Okay, now check this out. Now I've got minus, and I'm going to do 2 times the derivative of y. Now the derivative of the square root of y, I'm going to take the ordinary derivative, so 1 over 2 times the square root of y, but then I have to multiply this by the derivative of my inside function. I'm going to multiply that by dy dx, okay? And this is the chain rule. When the x and the y do not match, then you have to do this. You have to take the normal derivative, and then you have to multiply by dy dx. Okay, the derivative with respect to x of 0 is just going to give us 0. Okay, so now what I want to do is, first of all, I'm going to rewrite my derivative. I'm going to go ahead, I know I can divide out these 2's. All right, so I'm going to rewrite it as 1 over 2 square root of x. Okay, let me just rewrite that. All right, that's the bell for lunch. Lunch has been canceled due to lack of hustle. Okay, let me rewrite this as 1 over 2 times the square root of x minus 1 over the square root of y times dy dx, and that's equal to 0. Okay, so now what I'm going to do is I'm going to subtract 1 over 2 times the square root of x from both sides, so minus 1 over 2 times the square root of x. So then I get this. All right, I'm going to put my problem over here, and we get negative 1 over the square root of y times dy dx is equal to negative 1 over 2 times the square root of y. Okay, so now, what I would do to both sides here to get this solved for dy dx, I know I have a fraction here. I'm going to multiply by its reciprocal. So I'm going to multiply by negative square root of y over 1 and multiply this by the square root of y. So as a result here, oh, and this should be x over here, sorry. That's an x, folks. All right, so now what I've got is I've got my derivative, dy dx, is equal to negative square root of y divided by 2 times the square root of x. Okay, and this is my derivative. It contains both y and x. Okay, and it's important that I have this. All right, so what I want to do now is I want to figure out the slope. Okay, so I'm going to, in order to figure out the slope, I need to evaluate dy dx, okay, at the point x equals 4 and y equals 1. So if I do that, I'm going to plug that in, and I'm going to get negative square root of 1 divided by 2 times the square root of 4, okay? And as a result, that's going to give me, oh gosh, this should be a positive. All right. Sorry, the derivative is negative over negative, so my derivative really becomes the square root of y over 2 times the square root of x. So it should be positive, so my bad. Let me erase that. So we end up getting the square root of 1 over 2 times the square root of 4. So that's just 1 over 2 times 2, which gives me 1/4. Okay, and that's the slope at this point. Okay, so here's 1/4. All right, so now what I've got, I can write the equation of my tangent line, and I can just write y minus 1 is equal to 1/4 times x minus, what is that, 4? And that's it. Okay, so that's pretty reasonable. Let's go ahead and check the next one. I know we're kind of going out of order here, so we go all the way back to 6, okay? But I wanted to do this because you got some weird points here, and this is an exponential function. So, all right, so now let's do this one. Let me rewrite this first as x equals e to the y. And I want to take the derivative with respect to x, okay? So what I can do is I'm going to take the derivative with respect to x of each term. So the derivative with respect to x of just x, and that's equal to the derivative with respect to x of e to the y. Okay, let me make that look a little bit nicer. E to the y, okay? So if I take the derivative with respect to x of just x, it's just going to give me 1, okay? If I take the derivative with respect to x of e to the y, then the x and the y do not match, so I need to take my normal derivative and then multiply by dy dx. So I get e to the y times dy dx, okay? Now, I'm going to divide both sides by e to the y and divide by e to the y. And I can solve for dy dx, and I get that dy dx is equal to 1 over e to the y, okay? Now, remember, guys, what I'm trying to do is I'm trying to write the equation of my tangent line. I know that x is equal to 2. I know that y is equal to the natural log of 2, okay? But I'm trying to figure out what my slope is, okay? So I can figure out my slope by taking my derivative, dy dx, and plugging in x, by plugging in x equals 2 and y equals the natural log of 2. So if I do that, then that's going to give me 1 over e to the natural log of 2. Now, guys, I know this might be confusing for you, but when I take e to the natural log, I'm just taking the inverse of that, and I get the input, so I just get 1/2 as a result. Okay, and that's my slope. That's 1/2, okay? So now what I'm going to do is I'm going to write the equation of my tangent line, and that's just going to be y minus the natural log of 2, okay? And that's equal to my slope, which is 1/2 times x minus 2, okay? And you can leave it like that, or you can put it in a slope-intercept form. I'm just going to leave it like that. So I hope that this video is helpful for you. You know, guys, the only thing that we're doing differently is how we find our derivatives, okay? And our derivatives, if you follow this step where if the x does not match with the y, take the normal derivative and then just multiply by dy dx. Okay, so I hope this was helpful for you, and this is part 2. We will have a part 3.